Oops, this is the second lecture of week six, and in fact, tomorrow we have a midterm, as you know. That being the case, what I would like to do is a few problems which will refresh some of your memory of what we have done. These are coming from previous midterms, so you can view it as, if you want, as a review. Now, the first problem is geometry like that. The holes are clamped, the inside surfaces are clamped, and you're applying a pressure on the two sides, tensile pressure on the two sides as indicated below. When you look at that, you should realize that this needs to be done with solid elements. The most appropriate element is solid elements, and use all planes of symmetry. And because of the loading and the nature of the restraint, we need to do only 1/8 of this model. In other words, you can cut it horizontally, you can cut it vertically, and you can cut it through the depth because of the way the load and restraints are acting. Now you have two choices: make the whole thing and then start splitting it with the appropriate planes, or you can make 1/8 of the model. Entirely up to you. That's what I'm going to do. I will make 1/8 of the model. Okay. So let's go ahead and do this. It's a part, so I'm just going to get rid of that. Let's start with the part file. Right there. And I try something that resembles that 1/8 of the model, and in the front it's going to be 1/4 of the front view. So something like this, perhaps. Let me go. First of all, maybe I use a profile. So do it like so. We'll put dimensions in a minute. And perhaps close it like that. And then we have is half a circle. So I will do it like so. Incidentally, I just noticed that this center of that circle is not on that vertical axis, so I'm going to clean that up. So this point, control that, make it coincident so that it puts it exactly, yep. All right, now these two, and these two, we're going to make them concentric, okay? So this curve, this circle and that circle, we make them concentric. Okay. Now we're going to close this. Let's close that. For example, a line from here to here, and another line from there to there. Okay, we can now give dimensions. What do we know here? Dimension-wise, looking at these sizes here, maybe I should zoom in a little bit. So 1 radius is 1 and 0.5. Okay, 1 radius 1.5. So let's do that. This is going to be 1. This is 1. 0 inches. This radius is also 1. Control Z. Control Z. Let me make this 0.5 first. That does not mess up my 0.5. Okay, now that radius should be 1. Yeah. There's some other dimension that's missing here. Let's find out what else is missing. 0.5, 1, 1, 1. Oh, and this is 3. This is 3. Okay. That's what's missing here. So this is going to be 3. there. So this is one, uh, yeah, that's going to be 1/4 of that front view. And now we exit and add it by half the thickness. Now you're not in part design, so you have to switch to part design. We pad it by 1/2 inch. Good. Everything is made out of steel, so apply. I think it says steel, right? Steel. All right. So let's go back here and apply material to it. Where's the apply material? Oh, it's right there. On that part, choose the steel. Let's say okay. We're pretty much done there. So we're going to go to analysis and simulation, generative structure analysis. It's a static problem. All right, let's it's the problem says make sure there is a finer mesh around that hole. So let's do that. Remember how to do it. You go to the second icon and there's local mesh size. You select that. And right now it's this, which is fine. You just leave it the way it is. Now, generally speaking, I say default linear and default size. That's fine. All right, good. Now surface slider, there is surface slider on this face and that face and the back face and the bottom face, because these were all cut for symmetry considerations. And there is pressure of 200 psi on that face. Do not divide it by number 200, and it's tensile, so it's going to be negative 200 psi. Oops, wait a minute. Pascal, wrong. PSI. And just to make sure I don't make a mistake here, so I'm going to go to tools, options. Remember, there are no part marks for different things that you do wrong. So under pressure, I don't want pressure, I'll put PSI. Where is that? PSI gauge, PSI, pound per square inch. Let me see. There. All right. And also, stress. Well, let's see if this does it. So let me see for a second. Yeah, 200 psi. Good. So now we're going to run it because there's nothing else to do. It's fairly straightforward, very simple problem. Okay. Say okay. And look at the deformation. And you animate it. It behaves the way it's supposed to. Okay. Good. So I haven't saved anything, but make sure you do it properly. Save everything. Part and analysis has to be submitted for marking. Now we go to the second problem. There's a second problem. And we have done something like that, but anyway, let's try it. So it says use the most appropriate element. Obviously, you have to use beam elements here and use as many planes of symmetry as needed. So these are clamped and we apply a downward force and a moment here. Okay, let's see now. It says we displace this thing by 0.001 inch and we twist it by 2 degrees. Actually, I think we have done a problem similar to this before. All right. So, and then it says, what is the twisting moment needed in pound force per inch? Okay. So first of all, because of symmetry, I need to do only half of this model, and you have two choices. You can make the whole thing and then cut it, or just make half of this the way it is, okay? And if you want, you can make a line, line, circle, or here, see that? Because this is all in the same plane, we can make a sketch, and then this piece, we do it as a line later on, okay? Let me do that. All the dimensions are given here, so let me go ahead and start with the part file. All right. And then on that vertical plane, okay, on that vertical plane, I will sketch. It, it may be a good idea. It's entirely up to you because it really doesn't matter. However, um, you can draw this sketch that I was talking about on the XZ plane, or you can create a plane which is how many inches away, which is uh, 15 inches away, 1.5 inches away, and draw it on that. Okay, think that's entirely up to you. I don't know how you're going to do that. So I just told you how I proceed in doing that. Let me just find these dimensions here. Yeah. So here's what I'm going to do. I create a plane, offset from that by one by uh, 1.5 inches. Okay, and on that plane, I draw that sketch. It's entirely, as I said, it's entirely up to you if you want to do it point, 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 line, line, circle, etc. Be my guess. That's I'm going to do it a different way. So let's see now. Maybe something like that. We're going to dimension it in a minute. Come down here. Okay, good. Let's put dimensions. So between E and F, it is 2. This must be 2 inches. This must be 2 inches. Yep. So let me see. This is 2 inches. Okay. And from F to G, from here to here, from F to G is also F to G is 2 inches. Let me see. The only thing is that when I look at this drawing, let me see now, from E to F, look at E to F. Oh, that's 1 inch. Okay, okay, that makes sense. So this is 1. Okay, that's a lot better. Now it looks pretty much like what I have here as far as the scale is concerned. And the radius of that is 1.5. So this radius is 1.5. Actually, what is this? Check that here. 0.5. 0.5. Radius 0.5. 0.5. Very good. And to make my job easier, you know what? I'm going to bring this line and put it on that axis, okay? So you don't have to, but I'm going to do that. This control that, I'm going to make him coincident. There. Okay. Exit. Right there. So what you see there, if I hide that, what you see there is actually this piece. Okay. So I need a line going from that point all the way to the a distance of 2. This distance is 3. Okay, so here's what I'm going to do. I'm going to make a line going from this point in the direction, let's do it point and direction, in the direction y, point and direction, in the direction y, by the value of -2. Or negative 1.5, not 2, 1.5. Oh, Control Z, Control Z, 1.5, negative 1.5. Yeah, so what you see there is this. Good, good. All right, so what we're gonna do is we're gonna join all of these, okay? So obviously, as soon as you say join, you cannot do it here. So we're gonna go to mechanical design, wireframe and surface design, get the join icon, select this and that, okay, and everything is made out of steel. So apply material, steel on that part, you say okay, we're pretty much done here. So we're going to go to mechanic analysis and simulation, generative structure analysis. First thing we're going to do is to mesh this fellow. So we use a beam measure, use this, and I'm going to make a 0.2, maybe I'll make it 0.1. Okay. And then you do a 1D property on the whole joint. It's a circle. Now notice that these are two different sizes. Okay, so what I can do, I can make everything first the same as that, and then do a local 1D property to make this one different. So this is 0.05. Okay, so here's what we're going to do. We're going to say 0.05. Yep, that's good. Say okay. And then we go here, put the cursor on it, right click, local 1D property, and this piece is going to be 0.01, 0.01. Okay, so this section, this is 0.05, and this one is 0.01. Good. Actually, you can see that it's very small. You can see that. See, 0.05, 0.01. All right. That's pretty much it. So now we're going to apply a clamp at this point. You were told that this point is clamp. Okay. Now remember, this point is in a plane of symmetry. So let me hide first of all these properties so that I don't see them. All right. So this is in a plane of symmetry. I'm going to click on that and I write down symmetry. Uncheck all of these. And it lies in the XZ plane. So that point lies in the XZ plane, does not move in Y. Rotation is opposite. Good. And then I want to push this point down, right? So I'm going to hide that for a second. Another one. Push down. So I'm going to say push down. Push down. Push down means first you make it 0. That means 0 in the direction Z of this point. Okay. And then you can change it. So you click on this enforce displacement, you select that, and you say negative 0.001. I think that's what it said, isn't it? Push down by 0.001. Okay, and rotate it by 2 degrees in the direction that is shown. Okay, so say okay, and then we hide this, we hide that, and then again user define. I'll call it 2 degree twist, and the direction of it must be, you have to do it very carefully because it is important, obviously, how you twist it. So that point, first you make it 0 about y, because then we're going to change it. Okay, and now we're going to say you enforce displacement, you select that, and in the way it says 2 degrees, it's shown like that, is negative 2 degrees. Negative 2. Because look, y is going this way and you're twisting it the other way. You say, okay, good. And that's pretty much it. We're going to run it. Hopefully we didn't forget anything. Okay, look at the deformation. Let's change this thing to average ISO so that we can see it. Change the rendering to material. There we are. And you can animate it if you want. I don't know what you're going to gain by doing that. That's reasonable. Okay, good. Now it says how much torque is needed, how much twisting moment is needed. Okay, so first of all, let me change my units for torque into pound, what is that, pound force inch. Tools options. Units, magnitude, let me find moment. So torque is a moment. Oh, pound force inch, which is good, exactly what you want. So then we're going to put the cursor here, right click, create a sensor, reaction sensor. We select that twisting thingy, 2 degree twist, and say update moment, this number. It's a very small number, I understand that, but think about the size of this wire is 0.01 inch. So these are all dummy numbers, okay? I mean, 0.01 inch radius, it's pretty much nothing. It's like a thread. But anyway, if we take that, you take this number, multiplied by 2 because there are 2 pieces involved here, and this number multiplied by 2 goes in this box. Okay, excellent. So that takes care of this problem. Our final problem is this problem. Okay, so let me quickly do that. I'm going to ignore all dimensions, please, because see for a second. I want to know how much time I've got. Okay, no, we've got plenty of time, so I will use the dimensions that are given here to solve this problem. You look at that, and you realize that this has to be done with shell elements, and the loading and restraint is so that this hole is clamped, and you apply a pressure of 10 psi there. Thicknesses are different, but that's okay. We'll take care of that later on. So obviously there's going to be a plane of symmetry. So there's only one plane of symmetry, and you cut it like this. All right. and proceed. Now you have choices to make. In other words, you can make the whole thing and then cut it, split it with the appropriate saw, or you can just make half of it. I'm going to make half of it. Okay. Uh, no, I'll make the whole thing and then split it. Let's go back here. We'll get rid of all these. We don't need it. All right. Let me start with the part file. Say okay. So on that plane, I will sketch something that looks like what I have, and we'll clean up the geometry in a minute, like this and like that. And then we have some dimensions. For example, these dimensions are 2-inch, 2-inch, and these are 135 degrees. Okay, so let's see now. Let's take care of the angles first. This guy and that guy. 135. Excuse me. All right. This and that. Also 135. This is 2 inches. And this is 2. See? We have something else here. Let's see. Oh, this is also 2 inches. Okay, so let's go back here. So this is also 2. Okay. Now to make my job easier, I'm going to make the vertical axis to be symmetry axis. So left point, control, right point, control. Let's control that. Get rid of these things. Okay. I messed it up here. Delete. So this delete. And this is okay. So here's what I want to do. This point, control that point, control this axis. I'm going to make it this or symmetry. Okay, very good. Excellent. So exit. And this is extruded because I'm going to cut it later on in each direction by 2 inches. In each direction by 2 inches. So this way, right there, 2 inches. In the whole thing is 2 inches. So if I use mirror extend, it's going to be 1. So mirror extend 1 inch in each direction. That gives you a total of 2. All right, I don't need a sketch. I'm going to hide it. Now I want to draw a circle there. So on that face, I'm going to draw a circle, center, and we'll do the centering in a minute. And the radius of that circle is, I believe, radius of the circle is 0.25, right here, 0.25, okay? So dimension, diameter 0.5. All right, and we make sure it's set exactly halfway between top and the bottom. You know how to do that. Just control that. It's one of the ways. And use constraint in dialog box. And I can equidistant. Okay, exit. And I can use the split to cut that. So where is the split? There's a split. Cancel. Make sure nothing is selected. Click on the split. Element to cut is this, as cutting element is there. That's what we want. Now I'm going to draw a circle in that location. Okay, again, diameter 0.5. Okay, diameter 0.5. 5, say okay, exit, and then once again you split element to cut, cutting element, okay, it's fine. And finally we cut with the plane in the middle to get half of this. So split element to cut the whole thing, cutting element is right there, and it doesn't matter which side we pick, we say there. So what you see there is using symmetry, half of this is taken. Everything's made out of steel, so let's apply material to it. Apply material, steel on that part, say okay, good. And now we're going to go to analysis and simulation, generative structure analysis. We're going to use our good old, first of all, static, good old shell element right there. Let me change the rendering here, right there. See that? I select that. We make it smaller, maybe 0.2, but still linear. Yeah, good, that's good. And if you want, you can see the mesh. Right-click mesh visualization right there. I'm going to deactivate it. Now, what else we asked to do? So use all planes of symmetry and thickness. The thicknesses are different. Thickness of this is 0.025 and 0.025, but this is double of it. Okay. So we go back here, we make everything 0.025 and then change the middle. Okay. So we go here, 2D property on that whole thing, we make it thickness of 0.025. And then we say okay. And then you put the cursor on 2D property, right click local 2D property, you select that plane and you put the correct value, 0.05. Okay. Let's check that. Okay. Okay, so this one is 0.025, but down here is 0.05. This one is 0.05. Okay, good, good. Now we're going to apply symmetry restraint. Something was clamped. What was clamped? Let's see now. Oh, this is clamped. Okay, so let's go clamp that. Hide this. And then use the clamp. Select that edge. That is clamped. Okay. And then you apply pressure of 10 psi there. In the other direction. Basically push into it. 10 psi. And then symmetry constraints. So let me hide some of the stuff that's going to block my view. So for symmetry, user defined restraint, this edge, and that edge, and that edge, and that edge, and that edge, they lie in the, according to your drawing, or my drawing YZ, they lie in the YZ plane of symmetry, so there is no displacement in X, and rotation's opposite. That's pretty much it. You run it. Of course, you can look at the deformation, change the rendering to material shading. There we are. This is a von Mises stress distribution. We are not assessing the value quality of these things. It's just that you really have to do mesh convergence study in order to have any meaningful trust in your whatever you're getting. And mesh convergence study, I've already talked about it. You should know what it means if needed. That's pretty much it. So let's go to our last problem, which is something like that. And okay, this is the last problem that I'm going to be doing. When you look at this thing, you should realize that this is an assembly problem and it needs to be done with solid elements. Now, Let me tell you, if you model those vertical components, vertical cylinders a different way using beam elements, as long as it's right and it makes sense, uh, I'll be very proud of you. Okay. So, but as it stands, 99% of you folks are going to be doing this thing with solid elements, which is good. That's what I want. Okay. As I said, those other people who are doing these things a different way, I'm very proud of you if you can finish it. Okay. Now, what do we know here? First of all, these edges are completely welded to that horizontal piece. The edges are welded together, so that means that they're going to be fastened later on. These pins, let's call it pins of cylinder, cannot penetrate that piece, so there's going to be contact involved. The bottom of these things are clamped, and you're giving a gravity loading of 600 inch per second squared in that direction. Are there any planes of symmetry? Yes. So you can model it, cut it like this, in this direction. So just half of it or the other half. Can you make the whole thing and then cut it? Yes. Can you make half of the thing and then proceed? Yes. And that's exactly what I'm going to do. Okay. Notice that this is not a plane of symmetry. This is not a plane of symmetry. The only plane of symmetry is that if you see it says line of symmetry, it's a line of geometric symmetry, but it's not a finite element symmetry. Okay. So what I'm gonna do is I'm gonna draw this half a thingy up there, half of it, and then we proceed. Okay. So it's an assembly problem. I'm gonna start with the product file. So we start with the product. And insert, that's a horizontal piece, insert a new part in there. And I'm going to call it horizontal properties, horizontal member, horizontal member. Okay, let me do a copy and paste. I will make it. Let's double click on that. On that horizontal plane, I will sketch something that resembles what I have there. So maybe the easiest way to do it is through something like this, and then we dimension it in a minute. Okay, it's just that I want this control that, this control this, and the middle axis to be uh, symmetric. Notice that what it does, it puts the center of that circle on there too. And now we have some dimensions here. The distance from there to there is 6 inches. So dimension from here to there is 6. Okay, good. And this thickness is 3, so 3 inches. So that dimension is 3. 3. Okay. So we're going to make a circle there. And the radius of that circle is 0.5. Diameter 1. All right, and then I do half a circle here or a circle. We clean it up. We can do that. Dimension it also diameter 1. But I do have to do a cleanup here, so I'm going to use a quick trim. There is a quick trim. So I'm going to get rid of this line and that line. Oh, cancel. Let me see what happened here. Try it again. This, okay, let's say yes. Yeah, there you are. Fine. If you don't know what it says, just go ahead and make it a different way. Exit, and this is padded. Obviously, you have to be in part design to do that. Padded by, I think the thickness of those things is 1 inch. One. Okay. So there we are. And then we go all the way to the top. Say insert, new part in there. I say left pin or right pin. Properties, right pin. Right pin. Let's double click on it. So on that top face, I will sketch. Why don't I project that circle right there? Say OK. Exit. And we pad it downward by, what's the length of those things? 4 inches. 4 inches. So we pad it down, flip direction, 4 inches. We say OK. And then we go to the left, the center pin. How about double click, insert new part. No, we'll call this thing center pin. Center pin and center pin. We're going to make it. Double click on it. On that top face, I will sketch. Why don't I project that half a circle? Project that half a circle there. And I can close it. I have to close it because otherwise I can't pad it from this point to that point. Exit. And then pad it in the other direction also by 4 inches. There. All right, everything is made out of steel, so I'm going to go all the way to the top level. Please remember that you're doing an assembly problem. You have to give me the product, all the parts that make it, in this case there's 3 of them, and the analysis later on. Okay, so we make this thing out of steel. That, say okay, and we're pretty much done here. So we're going to go to analysis and simulation, generative structure analysis. Let me change the rendering here. Good. All right. What about symmetry? Okay, let's use symmetry considerations. So surface slider on this and that and that. Okay, good. The bottom of these two are clamped. So let's do that. Clamp here, clamp there. Okay. And we have to create connections. So let's do the following. I'm going to create 4 connections, 2 contact and 2 fasten. So connection 1, I'll call this thing center, so center pin, center pin, contact. First component, this surface. The second component, hide that fellow, and that guy. This is going to be contact. And while we're doing these things, we might as well make him contact as we want it. We can do that later, or we can do that now. So here's a contact. That guy there. All right. And then we have the edge. Where is the contact thing icon is over there. And then we want to do this edge and the edge of the pin. So another connection. I'll call it center pin. Fasten. Fully welded, right? For the first component, I select this edge. Anything that's blocking you, just hide it. This edge. And for the other one, we select the edge of this. Let me hide that. The edge of that guy. Okay, we're going to make this thing fasten. So where's the fasten? It's the third one from the left. This one is fasten. And we repeat this thing with the other guys. So another one. I'll call this thing left pin contact. And what I mean by left pin is this. Okay. So this surface, for the second component, you go select the surface of that hole right there. Okay. And we're going to make this in contact. We know how to do that. There's a contact right there. And finally, I call it left. I should have called this thing right pin, not left pin. I meant to call it right pin, but that's okay. All right, so unfortunately, I gave it different. So here, I'll call this thing again because I made a mistake once. I'll do it again. Left pin fasten. Left pin fasten. For the first component, I select this edge. For the second component, I go and select the edge of that hole. Let me bring this thing in the front. Let me hide that guy. Now it's going to be another edge, and this is going to be also fasten. So find the fasten. That guy. So okay. And the gravity acts in the direction Y. Let me bring this thing in the front. All right. So gravity, the loading is right here. Acceleration. All three pieces are subject to gravity, all three of them. Do not just select this top guy. You also have to do these pins, but in the proper direction. Direction Y. Direction Y, 300, what was the number? 600. Doesn't matter whether you do it positive or negative because depends on how you look at it, right? Which side you look at it. Good, good. And don't forget you have to save, etc. But I'm not going to do that. We just go ahead and run it, and this will bend to the left. That's fine. I don't think it asks us for any local mesh sizes or anything. And if it did and I missed it, I lose marks. That's pretty much it. There's no mention. I don't see any mention here. Yeah. So this should bend to the left. Otherwise, I've done something wrong. Right there. And then you can find all kinds of things in it. Stresses, deflections, etc. So that takes care of all four problems.